In last video, we went over ellipses that were centered at 0, 0 with a major axis along the x-axis, meaning it was stretched, right, along this x-axis right here. So it's stretched horizontally. Now we're going to go over ellipses that are still centered at the origin at 0, 0, but now their major axis is along the y-axis. So this almost looks more like a circle, but you can't tell it is just a little smushed. And so now these are going to be stretched vertically. Okay. So I again know this is at 0, 0 because you have x squared, y squared. When it is not centered at the origin, you're going to get an x minus h and x minus k that's going to move it from the center or from the origin. So if you just have x squared, that means this was 0 for your h. If you just have y squared, that means this was 0 for your k. So x squared, y squared, origin. Okay, the foci are still labeled as C in the vertices, and when they just say vertices, they again the major vertices are still labeled as A. And so you can see my major axis is the y-axis. You've got your two foci along that major axis, and then your two major vertices along the major axis as well. So we still have our minor vertices that are going to be labeled as B. Now, when I compare these two formulas, they both start with x squared and they both have y squared second. What switches is the a squareds and the b squareds. When this is a major, when it has a major axis along the x, your bigger number is underneath the x-axis. When your major axis is along the y-axis, A is still bigger than B, so now my bigger number is going to be beneath my y. Okay, and then this formula here still comes from Pythagorean theorem of this triangle. This does not change when you have an ellipse with a major axis along the x or y. That formula will stay the same. Okay, so example 3, analyze the equation. That is, find the center of the vertices, the foci of the ellipse, and graph. Okay, I forgot to say this last time too, and I forgot again. This equation here always needs to equal 1. So when I look at this equation here, I notice that this equation equals a 16. Now, I still know, even though it's not exactly in this form, that this is an ellipse. This would be a circle if that 16 wasn't there. What makes a circle is that it's not stretched in any way, right? It's equal distance all the way around. And to make that equal distance, you have to have the same coefficient in front of your x squared term and your y squared term. Because this one's a 16x squared versus a 1y squared, I know that this is an ellipse just by looking at it because those aren't even. Now, regardless, because this is an ellipse, I need this to equal 1. So we will do 16x squared plus y squared equals 16. To get this to equal 1, I need to divide everything by 16. So 16 divided by 16 is 1. You can just leave this as x squared, but so that I can see my b squared, I'm going to put this over 1. Plus, this will be y squared over 16. I can't do anything with that, but now it equals 1. Okay. So now that I have this in the form I'm looking for, now let's find the center of the vertices and the foci. So the center is easy because it's x squared, y squared. I know that this is 0, 0 again. My vertices come from my A. So which one of these two numbers are my A? Well, my A is always going to be the bigger number since A is bigger than B. So this is my A squared, which means A is plus or minus 4. So let's go ahead and plot the center. And I know because my bigger number is under the y-axis that it is stretched vertically, it's going to be longer up and down. So when I go to plot my vertices, I'm not going left and right like I did last time. I'm now going up 4 and down 4. So my vertices are 0, 4 and 0, negative 4. My foci is represented by C. And C is not in my equation, so I need to use this formula to find my C. So this is my B squared. So therefore, my B equals plus or minus 1. So before I find C, I'm going to go ahead and use this first to plot my minor vertices. So I'll go left 1 and right 1. And so this is my super stretched out ellipse. And again, as these numbers get further and further apart, the skinnier these ellipses are going to get. Okay. A and B is really all I need and the center to graph these, but we do need the foci and we need to label it on our graph as well. So use your formula here. We have B squared equals A squared minus C squared. My B squared is 1. My A squared is 16. And I don't know C, that's what we're solving for. So subtract your 16 over, and we will get negative 15 equals negative C squared. Divide everything by negative 1 to get 15 equals C squared. So therefore, C is the square root of 15. And that cannot be simplified because that's only 3 times 5, which doesn't have a pair, so nothing comes out. But to graph my foci, I do need a decimal equivalent. So that's about 3.9. So my foci is going to be really, really close to my vertice. Okay, probably going to be even closer to that because that looks like negative and positive 3.5, but you know, I already made my dots big. And so then when you label what your foci is, you went 0 left or right, and then you went positive 3.9-ish. So this is 0 square root 15. And then you did the same thing, but you went down. You went 0 left or right on your X. And then you went negative 3.9 down. So this is negative square root 15. And I probably should have even put right here plus or minus, plus or minus. Okay, example 4. Find the equation of ellipse having one focus at 0, 3 and vertices at 0, -4 and 0, 4. Graph the equation. Okay. So I'm going to go ahead and graph these points first. We got 0, 3. Okay, that's a focus. And remember, when they say vertices, they're referring to the major. So 0, -4 is major vertice, and 0, 4 is my other major vertice. So graph the equation. So because my focus and my major vertices are on the y-axis, let's first just note that my major axis is the y-axis. That's important because now I know that my equation is x squared over b squared plus y squared over a squared equals 1. I should also note that this already tells me that I know my center. And I do know my center, but it's not actually given to us. So with the center is always equal distance from your vertices. So since I was given both, if you keep going until you meet the middle, then we know that the center is right there at the origin. Okay, so I do know that the center is at 0, 0. Okay, again, because they gave me both vertices, I can count till I get to the middle, or even use your midpoint formula. Okay. So my focus is always labeled as C. From the center to the focus, C is 3. And really, let's go ahead and just make that plus or minus 3, right? So I actually know that my other focus is down here. So this will tell me that my C squared is 9. And then vertices are labeled A. And so here, A is plus or minus 4. So therefore, A squared is 16. So I do know A squared. What I have no information on is my B. So let's find B, and we will find B by using our formula of B squared equals A squared minus B squared. So B squared equals 16 minus 9. B squared is 7. So finding the equation, I know all of this. We've got x squared over b squared 7 plus y squared over a squared equals 1. That's my equation. So now to finish graphing the equation, I need to put my minor vertice. I can't say minor very well. My minor vertice on my graph. So if b squared is 7, then b is plus or minus the square root of 7. That can't be simplified, but I do need to get a decimal equivalent here. And the square root of 7 is about 2.6. So roughly 2.5 when we're graphing it, right? So we'll go 2.5-ish. That is my minor vertices, so lowercase m. And 1, 2, and some change in my other minor vertices. So now that I have all my vertices, now I can graph, and that's a darn good ellipse. Okay. So we now know how to graph ellipses when they are at the center with major axes along the X and Y. Next video, we're going to shift this from the center, but nothing really changes other than moving it.